Okay, Mr. Hunt here, talking about constructions. What I'd encourage you to do on these is I'm going to run through some constructions, but I would also highly encourage you to really try and think about, with these two tools, you have a straight edge. Remember, this is supposed to be unmarked, so you got to disregard any of these lines 3, 4, any of the numbers. It's supposed to be unmarked, so imagine you can't use any of those lengths. So you can basically make a straight line with this, and with your compass you can make a circle, a whole circle, or just an arc. With those two tools, how can you make all of these shapes and lines and things that we're going to do? Okay, so that's what construction is, using these two tools to make all these shapes. So I'm going to run through some. Let's start with number 1. Copy the segment. This is the first, really original one. Most basic construction. Copy or make a congruent line segment. So I'm going to call that A and B. Focus. Alright, so I'm going to call that A and B, segment AB. I'm going to copy it over here. To do that, I'm just going to make any line segment. I'm going to make it longer than AB. So I'll put A here. So this is the basic one. How can I do this? Well, I made a straight line. I'll put A there. And then I'm going to take my compass. Now when I say, I'm going to say I set my compass on, that means the metal part. So I'm going to set my compass on A. It actually doesn't matter here, but A. That means the metal part. Set it to a length of B. I have to come around here. Alright, so basically I could draw a whole circle if I wanted, but I only need that length there. Then I'm going to come over here. So I have on my compass that length AB. I'm going to do the same thing. And so there we go. There's point B, and we copied that segment. Okay, feel free to, as always, pause the video as needed. Here's star of this one, very important one. Construct a perpendicular bisector. So cutting a segment in half and making a perpendicular right angle. So there's our segment. We're going to make a segment that goes through the middle, the midpoint, and is perpendicular to it. This one's pretty fun, and it's pretty simple. You're going to do it a lot. Put your compass on one of the endpoints. Doesn't matter. I'll choose the right one. Make sure it's on the endpoint. Try and be as exact as possible. Set your compass length larger than halfway across. So right now I'm certainly over halfway. If it's not going to work if you go here, at least halfway. It could be the exact length. It could be a lot further. I'm just going to go there. I'll go about there. Now here's what you're going to do. I'm going to do semicircles. If you watch a video online, they will probably do full circles. Or, I should say, they might just do these arcs up here. Just like a little arc there, and down below an arc. I like doing full semicircles. So now I take my compass, go to the other endpoint. This is hard to do on here. I go to the other endpoint. I do that same, turn this, that same length and change my compass length. I draw my line where these connected. Alright, and what I did, this is now what I found. That is the midpoint, so it's perpendicular, and it and it was perpendicular, so I made a right angle. And that's it. So again, what you might see online, if you look it up somewhere else, what you might see online is you have that. They might start here, make just that, go over here, make that, all the same distance, but they didn't do the full semicircles. They just did this. Okay. And by the way, if you, let's say you did not go more than halfway, well, it just wouldn't work because your arcs, you have to turn this, your arcs would not cross. Okay, so you got to go more than halfway. I did say there, using congruent triangles, prove why your segment is a perpendicular bisector. We did this proof in our triangles unit, where because this segment pause for a second. So I'm actually going to skip that for now, but we did a proof of this property back with congruent triangles. Okay, for time's sake, I'm going to keep going here. Let's look at 4b. Okay, so construct a perpendicular line to the segment through the given point. Okay, again, this is 4b. I'm doing number 3, but what I need for number 3, this is very important, I should have highlighted more. For number 3 up there, you need, number 3, you need 2 endpoints. Alright, to do a perpendicular bisector, you take your segment, you need 2 endpoints. You always need that. So we come down here for B. I need 2 endpoints. Let's imagine that we don't know. Okay, darn, I should have had this point. I'm going to change this. Let's have this point, over here or something. So it's not. It doesn't look like it's right in the middle. So we need 2 points to go from. All right, what I'm going to do first then is extend my line. I need it to be a little bit longer, so I can do that. I have a straight edge. Extend any line I want. What I'm going to do to get 2 points that are the same distance away from this point is just take this, make sure that I'm going to draw an arc that goes through the line twice. So I'm just going to set it to about there. Make my arc. There we go. Where are my 2 endpoints? Right there and right here. So now I use those, and from there I repeat number 3. Okay, so I'm repeating perpendicular bisector. More than halfway. Okay, so that's fine. Come over here, I'm going to have to move this. Keep it the same as where we were. Sorry, I always teach sliding the paper, and it's hard to do on here without moving the camera on the paper. So, alright, so there we go. Should be good now, and so now I can draw on my line. So it was perpendicular to this line, but it also went through that given point. Okay, I'm on to 5A. Construct a line segment. 5A A and B are the same. Line segment through that point that's parallel to this line. I'm going to show you 2 good methods. There's more. I at least know of 1 more. I'm sure there's others, but I'm going to show you 2 methods. Both are good. You might like B a little more, but the reason I want to show you A is I believe I remember an error proof where it was diagrams and it showed you a method, and it was this method, that 5A angle copy method. So let's do this one. Make a parallel line. Basically, I'm going to make an angle and copy it. What I'm doing is, oh here, I even said it. I'm going to make corresponding angles that are congruent. I'm going to make these angles here be congruent, and if those are congruent, we have a theorem that says it's the converse of corresponding angles theorem. It says, well, then the lines are parallel. So first you need your transversal. So draw on any line you want here. I like to make mine a little slanted. Next thing you're going to do is make this angle. So put your compass on point A and make any angle you want. Now I'm not going to make it super big like that. I'm going to shorten it down. Okay, so I'm going to make any angle. You're going to copy that angle up here. Now I'm not doing a pure copy angle yet. We'll see that in the next section. But I'm going to make an arc at A. Let's call this B up here. So make an arc with your compass compass on A. Make any arc you want. Keep it the same, move it up to B, and make that same arc. Okay, so it's looking good. We kind of have two. A is a full angle. We have all of that. We don't know where this line would go here for B, and we can't just draw it in what we think it would be. So how do we get that length? Well, we use the angle starting at A. Here's what I have. I'm going to turn it this way for you guys. I have, if I put my compass on this point, I'll call it C. If I put my compass on C, I can measure out how far it is to where it connects down here. And I'm going to make a little arc. And it is important to make that arc so I know that you're not just kind of randomly doing this, you're doing the correct method. So I make that arc there, then I bring it up to what I call D, and do that same arc. And where it connected there, that's where I connect point B. Okay, and looks quite good actually. Very parallel. So again, the more accurate, more precise you are, the better it's going to be. Let's do B real quick. So same construction, but different method. I'm going to do the rhombus method. You could also do a parallelogram, because here's the reasoning. Both rhombi and parallelograms, opposite sides are parallel. So basically all I'm doing is making a rhombus. Alright, so let's redo the same construction. Here's how you start though. It's the same thing. You draw on any transversal, any line you want. Now I'm going to make my rhombus. So rhombi all have 4 congruent sides. So the side length is going to be this length here, from what I'll call A up to B. Set compass on A, go up to B. Trying to be pretty precise here. Okay, so you need that length. I made a little arc. You can kind of, if you watched a video of this online, they might only do this part and then bring it down here. I'm going to make the whole arc here. So let me take it off for a second so I can do it better. So I made that whole arc. Let's call this C now. So basically, here's AB is one side of my rhombus. I'm going to mark it. AC is another side of my rhombus. Okay, those are congruent because they're the same arc length. These are each. If I were to draw the whole circle, AB and AC would be radii of my circle, and so all radii are congruent. Okay, and so I need one more point. So for my rhombus, it's going to be up here. To find it, I'm going to keep, I still have the same length set here. I'm just going to go both to C and to B. I know it's got to be somewhere over here, going up here. So what I'm going to do is just make an arc. Again, you could do full circles if you want, but I'm just going to make these arcs out here like this and do the same thing here. So I made the same arc from both B and C, and it gave me this point, which I'll call D, to complete my rhombus. So then connect these. I guess I don't really have to connect D and C. I can if I want, because we weren't actually told to make a rhombus. We were told to make a parallel side. And there we go. These are parallel because opposite sides of a rhombus are parallel. Okay, thanks for watching. That's been segment constructions. Move on to angle constructions next.